actually get started.
Can you hear me fine?
Yeah, go ahead. Okay.
So this is sorry.
Go ahead. Hello,
Okay.
everyone.
Your voice
Welcome to
is very faint, guys. At the chair. So it's the top of the hour, so I guess we can get started.
Yeah, let's get
Especially
started.
we. Yep.
Okay. Good morning, everyone. Welcome to the Inter-Area Working Group meeting. With me today, my co-chair Juan Carlos is joining us remotely, and Carlos Bernardos is going to be with me here. So let's get started with the chair slide. Go ahead, JC.
Welcome everyone to the Inter-Area at IETF114. This is an IETF official meeting, so the usual not well goes. Therefore, we have this reminder that IETF policies on topics of patents and code of conduct, how to present yourself and address your colleagues, are in effect. By participating, you agree to the IETF processes and policies, and of course, if you are aware of any contribution covered by patents, please speak up or send us a note to the chairs. Also, for your information, everything here is going to be written audio and video and photo may be made public, and the personal information that you provide to the IETF will be handled accordingly to the IETF privacy statement. If you have any questions, you have the references there to the different BCPs. So please make sure that you sign into the session using the Mitico. We will ask you to use Mitico to join the queue so that we can control local and remote participants and the order of questions. Keep audio and video off if you're not using the on-site version. We ask you guys locally to wear masks unless actively speaking at the mic. If that makes your voice clearer, you may be able to remove your mask at the mic. And for the remote participants, please make sure that your audio and video are off unless you're chairing or presenting the session. These are the links to the agenda, Mitico and other information. And if you have any issues, please report it back. So once again, the minutes are taken. We will need you guys to log into Mitico as a blue sheet for the data tracker. For the scribes, there's a notes for Inter-Area, and there's a chat room both on the Mitico and on the Zulip tool. At this moment, I guess we can ask for a note taker. Can someone help us with the notes?
Ladies and gentlemen, we need please a note taker. Any volunteer? Please.
I can offer my help as the last time offline. I mean, I will prepare it. Is that fine for the chairs?
Yeah. Thank you. Thanks, Luigi.
Thanks, Luigi. It wasn't very clear, but I guess you're offering to take the notes, and we can help, of course, also when you're presenting. Thanks. So, by the way, when you guys speak to the queue mic, don't get too close. It's going to be clearer for the ones that we are remote. So with that, we can move on to the agenda. We have a compact but dense agenda, starting with a few updates that we're going to give, followed by Fred's presentation on the Ip Parcels, together with some other drafts. Then we have the internet addressing considerations follow-up from Luigi, IANA considerations from Don Eastlake, and service routing and multi-access edge computing from Zhongpeng. Are there any questions or comments regarding this agenda? Okay, hearing none, we can move on to the quick working group updates. So the first one is we had this call for working group adoption of draft template INTAREA parcels. We had a heavy discussion on the mailing list, but so far we're not seeing any consensus to adopt the draft. So our plan is to continue this call for adoption until the end of this meeting, since Fred is going to present now. So we're going to be hearing one more round of comments, and then by the end of this week, we can close the call for adoption. And this presentation is following. It's going to be the first one, so that discussion can be both at this meeting and over the mailing list. The other update is the Internet Addressing Considerations draft from Luigi. It's being moved out of INTAREA. This was draft GIA INTAREA Internet Addressing Gap Analysis, and now it's draft Janone Internet Addressing Considerations. So same thing, we are going to have Luigi presenting and giving us an update about his draft. But these are pretty much the working group updates so far. Okay.
Thank you, JC.
Thanks.
We're going to start with the first presenter. Fred, please.
You want me to give you control, Fred?
We'll do it from here, JC, is okay.
That's all right, you can do it from there.
Yeah.
Okay.
Okay, so this is about Arrow and Omni and IP parcels. Next chart. The internet was originally intended as a network of networks. I'm standing on the X. Like that? Okay. The internet was intended as a network of networks. Beginning in the 1970s, the ARPANET grew to become what we know today as the global public internet. One of the first nodes on the ARPANET was the SRI van, the mobile node.
So, sorry,
Today's
Fred.
public internet.
Sorry, it's on the remote now. It's a little too loud. It was actually not bad before.
Is that better?
Yeah, that here is perfect.
So today's public internet is a single monolithic routing and addressing domain instead of network of networks. It's because there's incomplete architectural layering. Private intranets connect to the internet via security devices like firewalls, proxies, and NATs, but they use address translation so that there's no true end-to-end global addressing. And internetworking between private internets is problematic due to addressing and security incompatibilities, and this complicates global mobile internet working. But the early pioneers envisioned a true end-to-end communications over a global scale network of networks, and they even had a name for it. They called it the CatNet model for internet working. And I believe we're at a unique point in history where the end-to-end can be restored. Next chart. So here's the CatNet model for internet working. The figure that you see on the right is the one originally drawn by Vint Cerf in 1978. It was documented in IEN48, which was the precursor to the RFC series. It incorporated still earlier concepts from Louis Poisson beginning in 1974, and it envisioned a true network of networks. They knew at that time that gateways were required to interconnect diverse internetworks, but they did not know how to traverse them. And they knew that end systems also required a local gateway to support the end-to-end. What they did not know at that time is that they needed a new architectural layer, and that we call the adaptation layer. Arrow and Omni now provide an adaptation layer for the internet. Next chart. So here we have 4 disjoint internetworks. They might be, for example, large corporate enterprise networks, service provider networks. One could be the global public internet itself, the global IPv4 internet. Another could be the global IPv6 internet. But they're in disjoint partitions. So next chart. So if we deploy gateways that operate at the adaptation layer, we can now span these disjoint partitions. Next chart. And thereby have end-to-end communications both within the same partition and across partition boundaries by using adaptation layer forwarding over the gateways and over partitions. Next chart. So that what happens is an original IPv6 packet starting down in the bottom left becomes encapsulated in the adaptation layer, which is that orange encapsulation that you see, then fragmented if necessary, and then encapsulated again as carrier packets is what you see in this green layer. The green carries the packets across the individual segments. The orange carries the packets across the adaptation layer gateways. And at the very far upper right, you see that the original packet then comes out at the other end after decapsulation and reassembly. Next chart. So the Omni adaptation layer, end or near end systems configure an Omni interface, which is essentially the same thing as what the CatNet model called the local gateway. The Omni adaptation layer source uses IPv6 encapsulation and fragmentation to produce OL packets, and then uses L2 encapsulation to produce carrier packets. The carrier packets traverse to the OL destination, which reassembles and decapsulates, and the source can tune its packet sizes without loss to achieve the best performance. It's very similar to ATM adaptation layer 5. Next chart. So in terms of multi-net traversal, we have these things in the middle called OAL gateways. Here again, the original source and final destination are in different internetwork segments. The OAL source produces packets and fragments, and the OAL destination reassembles. And the OAL gateways forward the OAL packets at a layer below IP, but above the link layer. You can see where that bend in the green graph there happens at the adaptation layer and below IP, but above layer 2. And the carrier packets transport OAL packets or fragments across first hop segments, then undergo re-encapsulation and retransmission at each next hop segment. And this provides us the opportunity for true end-to-end in the spirit of the CatNet. Next chart. So now let's talk about Aero Omni and the 6 M's of modern mobile internetworking. The adaptation layer naturally eliminates many challenges that complicate diverse mobile internetworking service models. Incremental deployment on existing networks, there's no need for a flag day. Security is addressed at all layers in the architecture, including end-to-end. It naturally supports DTN. And the 6 M's that I'm talking about are multi-link, multi-net, mobility, multicast, multi-hop, and Mtu Assurance. And all 6 of them deserve a 30-minute time slot in their own, but I'm not going to talk about all 6 today. Just understand that they're very important. But what I am going to talk about is Mtu Assurance, the ability for mobile nodes to send packets of diverse sizes without loss and to dynamically tune packet sizes for best performance. And it's inspired a new construct that's known as the IP parcel. Next chart. IP packets of both IPv4 and IPv6 contain a unit of data that becomes the retransmission unit in case of loss. Upper layer protocols such as TCP, Quick UDP, LTP UDP exchange segments and with a single segment per IP packet. But IP parcels permit a single packet to carry multiple upper layer protocol segments as a packet of packets. But the segment is still the loss and retransmission unit. The goal is to support larger packets for better performance, flexible packaging, repackaging for more efficient handling, and to encourage a more diverse maximum transmission units in the internet. Next chart. So as an analogy, when a consumer orders 50 small items from a major online retailer, the retailer doesn't ship them in 50 separate small boxes. Instead, they put as many of the small items as possible into one or a few larger boxes or parcels. And then they place the parcels on a semi-truck or an airplane. The parcels arrive at a regional distribution center where they may be further redistributed into different sized parcels that are finally delivered to the consumer. But most often, the consumer will only find one or few parcels at their doorstep and not 50 individual boxes. And this greatly reduces handling overhead for both the retailer and the consumer. Next chart. IP parcels are formed by putting together segments that come from the same upper layer protocol 5 tuple, being the source address, destination address, source port, destination port, and protocol, to produce buffers with up to 64 segments, all concatenated together. All segments except the final segment must be equal length. They can be up to 65K octets, 64K octets, minus the length of the headers. The final segment may be smaller. And the upper layer protocol delivers the data buffer and non-final segment size to the IP layer. And from there, the IP layer forms parcels by appending a jumbo payload option. It's the same jumbo payload option that appears in RFC 2675. Next chart. So IP parcels are based on IP jumbograms. IP parcels use the jumbo payload option with a non-zero total payload length, whereas true jumbos use 0 for that field. The total payload length encodes the length of the first segment only, and the jumbo payload length includes the length of the entire parcel. IP parcels are defined for both IPv6 and IPv4. For IPv4, we're proposing to reuse the obsoleted RFC 1063 IPv4 probe MTU option. And the maximum IP parcel size, therefore, is a little bit less than 64 times 64K or 4 megabytes. Next chart. So here's what they look like, IP parcel structure. It supports both TCP and transports over UDP. They include up to 64 upper layer protocol segments, but only one TCP or UDP IP header. And the TCP UDP checksum covers only the headers with an individual trailer for each segment. All checksums are calculated in a single pass over the data. For TCP only, each non-first segment is preceded by a 4-octet sequence number header, and UDP transports encode their own star delimiter at each segment. Therefore, they don't need the sequence number header. And these sequence number headers and checksum trailers can be thought of as a compressed TCP or UDP header. Only have to include that much information that would normally appear in a TCP header, and then you can put all these items together as a single parcel. Next chart. Transmission of IP parcels. IP parcels traverse parcel-capable links with sufficient MTU, the same as packets. Parcel-capable physical links are not yet available, but Omni virtual links can forward IP parcels using the adaptation layer today. The Omni adaptation layer uses encapsulation and fragmentation to break large parcels into smaller subparcels if necessary, since the largest that can undergo IP fragmentation is 64K. In the first pass, we have parcel fragmentation, which is accompanied by loose reassembly with opportunistic merging. In the second pass, we have IP fragmentation, which has strict reassembly with fragment retransmission. But the goal is to forward the fewest and largest IP parcels possible over the network to the final destination. To minimize segment reordering due to reparceling if possible, although that's not critical. We'll leverage IP fragmentation, reassemble if necessary, and the lost unit is a single segment instead of the entire parcel. So before we start sending parcels, we have to qualify the path to see if the path is capable of supporting them. So we have this parcel path qualification procedure. We have a parcel probe from sources, test consecutive hops up to the destination or a router with a non-parcel capable next hop. And this is done by using a hop-by-hop option that's processed at each hop. And then the destination or the router informs the source that some or all of the forward path is parcel capable by sending a parcel reply. And for this, we use UDP IP encapsulated ICMP messages that are processed only at the source. But after a parcel path qualification, parcels from source traverse parcel capable paths the same as ordinary IP packets up to the destination router. Destinations that receive parcels can effectively deliver them to upper layers, and routers that terminate parcel capable paths open the parcels and forward individual IP packets to the destination. Now, this goes a long way of saying, why are we wanting to do this? IP parcel integrity, with link layer integrity checks, like CRC32, they can miss errors in packets larger than about 9 KB. But IP parcels are often much larger than that. IP parcels include separate integrity checks for each upper layer protocol segment. The parcels improve integrity compared to same size packets or jumbograms, which only include a single upper layer protocol segment integrity check. Only segments with correct integrity are accepted. Individual segments and not the entire parcel is the loss retransmission unit. And this is very important because If you send a parcel that has 50 items in it and only 2 are corrupted, you still get to accept all of the 48 other ones. So IP parcels now encourage new link types with larger and more diverse MTUs, plus improved integrity, resulting in major internet networking performance improvements. And that's why the why of doing IP parcels. And now we come to the question. IP parcels is ready for adoption as an inter-area working group document. Arrow and Omni are also ready for adoption as inter-area working group documents. Can we adopt IP parcels? And can we adopt Arrow and Omni? That's my charts.
Thank you, Fred. Just a reminder, the Int-Area Working Group initiated a call for adoption on June 22nd. And so far, as JC mentioned, we haven't seen enough support to adopt the draft. We have some time for questions.
Thanks, Fred. Stucard. Wondering if you have looked, affiliation, in this case, critical technologies. Wonder if you have looked at the potential interactions of this with the various TCP options. The one that I care about most is SCIP's options.
So with TCP options, they would appear only in the TCP header of the first parcel. If it gets broken out into multiple parcels, they would still only appear in the first parcel. The other parcels wouldn't carry the option. And it's the same thing with the TCP ACK flag. The TCP ACK would only appear in the first parcel, not in all subparcels after parcelization.
Okay, no more questions? Okay, thank you, Fred. Luigi, please. Carlos will run them for you if you want.
Oh, that's okay.
Do you
That's
prefer
okay.
as you wish?
Okay. Let me. I'm smaller than Fred. Okay, let's start. So this is an update about the discussion about internet addressing. We had 2 drafts in the past named problem statement and gap analysis. Now, as has been mentioned by Juan Carlos, the new update changed the name to consideration. Explain why. Next. So let me put a little bit of context in the next couple of slides to recap what this is all about. Next. So this slide comes from actually IETF114 when we presented the update on both documents. The problem statement provides basically a scenario that we have today in the internet where the addressing model that we have it can be a potential hindrance. So maybe sometimes things can be done in a different way. Then there was the second document, the gap analysis, that investigated a little bit more about these scenarios and actually also looking what kind of extensions in some areas have been introduced in order to go beyond what was looking like some limitation or shortcomings, okay? We had a huge discussion on the mailing list, various mailing lists, but mainly on Int-Area. Started from a side meeting that we did in IETF 112. Okay, and yeah, we tried to capture all the input that we received from the community. Next. So I think the animation that I put don't work now, but so you will see some awkward bubble in sometimes. But so the conclusion, this is the last slide that we showed in 113. was the fact that we were asking basically to have adoption, working group adoption, because we felt that while not finished, this is a good community effort. And we also suggested the fact that maybe we should start to think what's next. I mean, we have some considerations. So what should we do with this? Okay. Next. And people listen. It was great in the sense that the INTAREA chairs were ready to issue the working group adoption. Okay, but in the meantime, the IAB and the ISG organized a retreat. They have usually to discuss various things. Okay, but one of the discussion items in their agenda, and there is a snapshot here, was exactly about internet addressing. Okay, if you if you go on the wiki of the IAB ISG, you can find the agenda and then even the link to the slides. Okay, which I took the liberty to use a few of them since they were public. I must have handled this in a different way. Maybe I apologize if I didn't directly ask IAB ISG to do that. But the blame is completely on me. And next. So in the next few slides, you will see this, except the awkward bubbles, the slides come from the IAB ISG. There is the link on each and every slide stating the source. And I would like to ask Eric to help me to set the context of each slides.
Okay, thank you, Reggie. So my name is Eric Vink. I'm the Internet Area Director. And indeed, those slides were prepared by Colin Perkins. It's maybe in the, on the meeting call right now. Basically because we were seeing a couple of drafts about this. We sometimes kind of, hey, Colin, nice that you were about to join us. We were wondering basically what was the intent of UEG at this point of time. So we reuse basically the retreat to say those two documents, and that's what I wrote on the right, there are multiple authors, a little bit too much, right? Too many, but it's okay, including academic, and you are also ex-academic there. And there were basically multiple gaps in those addresses. It was a quick summary of your draft, basically on about the lengths, sometimes about the semantics, the confusion between locator and identifier, which I think everyone will agree with you on this one, except for the name of gaps. That's the reason why I put there, because it works, right? The internet works. And basically the authors were making this statement, and I don't disagree with it, and proposing nothing, right, to do. And it was kind of puzzling for us. That's the context of this slide.
Yes, exactly. And I agree totally what you said. It's cool that you see that there are several authors. Yes, the use of gaps maybe is not the right wording will come. This is the reason actually why there is a change of naming in the document, and we'll talk about this, I think, in the next slide. No solution proposed. This was absolutely on purpose. As we say in the problem statement, the document is really not about proposing specific solution, but as I put it in the awkward bubble, is aims at stimulating discussion. Okay, so there was no intention to go into the solution space, or at least not yet. Okay, next. So coming back to the fact that the gap analysis, it's true that the feedback basically, as Eric says, is that you use the word gap. It looks like there is a real issue, and you use a gap to describe something missing between two things. One is the current state, the other is the proposed solution, but we don't have the second one, so there is no gap in that sense. While we did some effort not to present like there is an issue in the IP addressing. Maybe we still use too much the word issue in the previous version of the document. So after discussion with Eric and the chairs, we agreed that on the mailing list that the word consideration sounds better. Okay, and so that is why there is the draft here non-internet addressing consideration. Okay, next. I mean, would be tedious to go in all the details in the changes that we did to this document. What you see here is just the diff between the old document and the new. The table of content already shows that the word issues disappeared. Okay, the point is not to and it has never been to say IP addressing is bad. It's good. It works perfectly. There are some scenarios where some solutions have been developed to overcome some limitation. Now the question is, can we do it in more coherent way, okay, instead of have point solution here and there that sometimes may be incompatible and sometimes can end up in introduce some kind of fragility. Okay, next. So I ask Eric to come back.
So that's another slide from the retreat, as Luigi kindly indicated at the below. We were really wondering what to do with those drafts, or what were the best suggestions to move forward with your work. Or there was about creating a research group, making an IAB workshop just on this topic, possibly creating a new working group, or keeping it in INTAREA. We were posing the questions there. I got some feedback from the IAB and the ISG, and basically it was the third point that was kind of selected or suggested as the best way forward.
Okay, so from our perspective, we are, these documents is not about research, pure research. So we don't feel that there is a place, or better, we don't need to bring completely this work into IETF. If there are research aspects related to this work, certainly we can go discuss to the various RC that cover the topic, obviously. IAB workshop is up to IAB, would be welcome, obviously. So what we focused on is the last two possibility. Next. But there is Suresh on the queue. Suresh.
Yeah, thank you, Suresh Krishnan. So keeping INTAREA, I'm not really for it, right? So INTAREA is supposed to do one-off things, right? Like
May I ask you to make this comment after the next two slides, because okay. I'm tackling exactly these points,
okay,
and
thank you.
I'll call you back to the mic.
Thanks.
Thanks, Suresh. So, Eric, you want to say anything on this slide? This is just the specific 2-point new working group.
That's, no, exactly. That's basically what I wrote as the benefit and at first sight, right? The benefit and the drawback of creating a new working group to work on this.
Is just one detail is that they mentioned Sion and Rina. I suppose you guys discussed also this, but yeah. Other than that, I mean, this is the let's say what should be done in order to go for a new working group. I mean, we know the procedure that there is. We know there is much work to be done, and the community has to be there. Okay, this is a community decision. Eric,
yeah, and something which is, you are right. So Sion and Raina, different topics that are not really related to this, but we put in the retreat in the same bucket. So forget, because it was not linked to your draft. And the incremental move is really what will be important for the next step, right? We don't want to invent a PV10, right? Just
absolutely. So the documents so far are not exhaustive, but cover, I think, all the main areas. Doesn't mean necessarily that we have to find a solution for each and every area. I mean, this is something also to be discussed and decided as a community, and to decide whether or not something should exactly be done in the different areas. So, I mean, as has been marked, let's not boil the ocean. Let's focus on something that makes sense. Okay. Next. Eric, you want to say something? This is just the other slide on the INTAREA is an excerpt of the charter, but which rightfully says what should be done here is something that doesn't fit in any working group in the internet area, but is not, let's say, enough to or worth it to create a new working group. So I think that if we go to the next slide, yeah, this opens the question whether or not we consider that the discussion about internet addressing should be considered as was to be discussed in a larger scope beyond the INTAREA, and so considering if there is sufficient energy and willingness to explore the possibility of a working group, or the community feels that the two documents that we have are a good snapshot of the situation, but there is no willingness to go further at this point in time. So we are happy to have any possible feedback. We also set up a side meeting tomorrow, early morning, 8 o'clock. You are very welcome to stop by and express your opinion, because yeah, we need to have consensus and energy to move forward. And Suresh, please, if you can come back.
Thank you, Luigi. So I think you kind of got to my point of view. So like it's the INTAREA is like, as I said, like, you know, it's like chartered for smaller work items, right? Like, you know, one-off things. And this seems to be like a large body of work potentially. So I think if you go for a new working group or new RG, like I think that might be better. And I say new RG or like, you know, existing RG as well as possible. Like, you know, for like maybe pan RG, I don't know, right? Like, you know, might be a home for it. The reason I'm waffling a little bit is because it's not clear if the problem's all understood and agreed upon, right? Like, so it might take a little bit of time before we get to a working group. And that's probably why I think Colin might be online. So the idea might be to kind of like solidify the set of issues that need to get done. And the only concern I have is to kind of make this incrementally deployable. So like one thing we don't want to do is like come up with another clean slate solution. And as long as that's there, like, you know, you're not going to see me coming and screaming at you. So thanks.
Thank you, Suresh. I totally agree with you in the sense that whatever we'll end up doing, this must be incrementally deployable. And also there is a work to be done on the scope on what we want to do. It's not just, oh, let's revise the addressing model. It's not that. It's what are the areas where if we do something, we get real benefits, and how do we do it in order to be incrementally deployable? That's the question. So there is some refinement work to be done on the scope and then solution space to be explored. Yeah.
Hi, Andrew Campling. This might be a question for Eric, I guess, which is if the purpose of the IAB is to provide long-term technical direction on the development of the internet, I'm sort of struggling to see why this wouldn't be a good subject for a future IAB workshop as a way to flesh this out somewhat.
I am on the queue.
Yeah, I know. You were hinting to me, Andrew. IB workshops are managed by IAB, right? Clearly. An outcome of the site meeting, I mean, everything is in flux because honestly, the problem is not well scoped, right? There's a reason why there are side meetings, maybe BOFs later, or maybe IAB workshop. So yeah, everything is possibly open. I understand it's not the answer you wanted, but it's the case.
I might be wrong, but the two things are not incompatible, right? If there are side meetings and discussion, doesn't prevent the IAB to organize a workshop. Am I wrong?
Joel Halpern from Ericsson. Luigi, I appreciate the goals that you've gotten in writing into this document. You and I have talked about it.
Yes.
but I can't figure out how to use this document as it currently lives as a basis for any discussion for what to do next. The document mixes things that are done with things that have been proposed. It mixes things which are done but work badly with things that are done and work well. It mixes ideas that have been proposed that probably make sense and go in IP with things that are application layer and don't belong anywhere near this. I don't know how one would even put together either a charter or further discussions in this group without significantly more clarity in what it is we are actually talking about. I mean, if you want to publish it as a survey paper in SIGCOMM, well, hey, you do good work, but that's not what we do here at the IETF.
So
I'm sorry.
Thank you very much, Joel. You have good points. Let me answer that. Two things. One is especially the consideration document, as we discussed by email, could be better reorganized, and some thoughts that are there are not clearly spelled. So there is quite some work to be done, but I did really appreciate your review. So this is one thing. Now on the fact that I cannot use these documents to explore a solution, do a charter, whatever, that's true. But because they were not written with that purpose in mind, as I said in a few slides before, the point was to trigger discussion, which is the reason I'm here, right? Now, if we do agree that is something to be seen, now we need to work in another direction and go exactly where you said, transform these documents in something that can be used to structure a charter, a discussion, or something like that. So there is work to be done in that direction. I completely agree.
I think we have another question from Colin. Or comment.
Yeah, hi. I hate to be that person, so it's not so much a question, it's a comment. I think one of the issues that I have with these drafts, I think, are very similar to the issues Joel just raised, in that they seem incredibly broad, and there are some aspects of these drafts that we have had research groups in the IETF discussing related topics for several years now. There are some aspects which are very straightforward engineering extensions to existing protocols, and there's they cover the whole range in between them. And given the breadth of the drafts, it is very difficult to know where the work should go, because the work doesn't seem to have a focus. It doesn't seem to be so much research, or clearly research, because it's covering about 3 or 4 different research groups. It doesn't seem so much to be engineering. It's not clear where it's going. So I would echo the previous comment. If you can focus the work and decide whether you wish to do research, if you wish to do engineering, and focus it down on a specific topic, I think you will find it easier to make progress, or at least it's a definitive answer where progress should or shouldn't happen.
Sure, thank you, Colin. That's a good comment. Is on the lines like Joel said. I do agree that is broad. Again, the reason is very simple. We try to let's call it a bibliography, as Joel said. We went broad to see what is going on. Doesn't mean that we need to tackle each and every different area or different scenario, etc., etc. So certainly there is a big work to be done in order to scope the things and in which direction we want to go. And might this change the venue? Maybe. The point at the beginning really was to trigger discussion, not to drive discussions. That is why we went broad, so that everyone can have a say on this. And we will continue to do in this way, and try to set the priorities according to what the community feels are the priorities or the most promising direction to explore. So what can I say? I do agree there is a lack of clarity. That is why we need more discussion, as my personal opinion.
Thank you, Stu Card. And this time I'll say my affiliation is with AX Enterprise. So on the one hand, I think this work is fundamentally important. And I believe that having a venue in which these various issues can all be discussed at the same time in the same room is important, because trying to tackle them one at a time, I don't think leads to the kind of solution that we ultimately will need. Your section 2 in your draft lists 8 different areas where issues exist. And in the drone remote identification protocol working group, we confront clearly at least 4 of those 8 and arguably more of those. So there is work in IETF going on that addresses, some of them for a particular application area. But so now coming to my question, you probably covered this in your slides, but I somehow missed it. Why IETF rather than IRTF?
So we documented all engineering efforts to extend the addressing model, and as Colin pointed out, and you can check it on the documents, there are not that many research papers as a reference. So we don't feel like that there must. We don't feel, but again, it's not me to decide. We don't feel that building a new RG is worth it, also because part of the things we cover in the documents are covered by existing research group also, that we can discuss specific research aspects in the existing research groups, I think. So that is the reason.
Actually, Dino was first.
This is Dino. So discussion is good. I agree it's helpful, especially face-to-face. But, at some point, you can discuss the depth and there's no progress. What I would suggest in the discussions is maybe we see how out of the list of problems or potential problems, let's see what people think about what's the most important single problem to solve. Like what address problem, what's wrong with IP addressing, and everybody has their favorite problems with IP
nothing
addressing.
wrong.
What?
We can provide extensions. There is nothing wrong with IP addressing. It's just that in some scenarios we can provide extensions that are meaningful.
Oh, all right, somebody could say, I love IP addressing, but the way we do proxy aggregation in BGP is a problem. Maybe we should work on this problem because we think it's going to help service providers. So that's what I would suggest, is pick one problem, and then we could focus, and then it's succinct, and it's described, and then we could explore solutions that either change something or extend it. I know change is and like you said, an important requirement is compatibility. So how much can you change to get a benefit and still keep it compatible and transition to it easy?
Yeah. Thank you. You are making the points I was willing to open tomorrow. This meeting. Excellent. Thank you very much, Dino.
Actually, I think Dino probably articulated it better than I could, but when focusing on particular issues, I really want to see more about what problems you're trying to solve specifically, right? So that's something that's quite weak in the document. It's kind of all over the place, but a lot of people have said that already. The other thing I would just say is just a sort of caution about thinking about developing things that are too complex going forward. So we're seeing quite a lot of protocol developments that are quite wide-ranging at the moment. And I would say, if you're thinking about these specific solutions, really have a one problem and one solution kind of thing. So that's just my feedback. Thank you.
Please state your name.
Oh, sorry. Dominique Lazansky, and I work for Last Parcel Label. Thanks.
Thank you. Yeah, I do agree with the comment. What can I say? There is one thing I personally want to add. I mean, there is nothing that is going to break. We see that just there are in several places extensions that are developed in a kind of independent way. The point is that just can we have something more coherent and bring it together? So we have time to discuss, and we have time to make the right choices. I mean, we don't are in a hurry. So yes, scope the problem, what we want to solve, what we don't want to solve, and how can we do it incrementally deployable, et cetera, et cetera. So this is all part of what is in front of us if we take the path of, discuss for larger effort than just 2 documents in the INTAREA.
Any more questions? Dino, go ahead.
This is Dino. I don't want to be redundant, but it's funny how if you just choose one specific problem that's well-defined and try to solve it, it ends up taking a life of its own, and then it sprawls out into other things that then could be solved because you have a firm problem statement and a solution. And so, you know, I mean, I always use RSVP as an example. We needed a reservation protocol on the internet, right? And so RSVP was developed. It was done in research and university, and it did solve the problem. It had limited deployment, but then it turns out that sometime later, people said, hey, RSVP might be a good protocol to do label binding in MPLS, and there's more deployment of RSVP-TE than there is for the original problem statement. So you see, just going down the path of just picking one succinct problem and trying to solve it may develop into a solution that somebody says, this is going to be good for, you know, holographic video in the future or whatever, you know.
So you are basically saying we will develop something that will go beyond our expectations. Wonderful.
It's always the case, right?
Thanks, Dino.
Okay, thank you, Luigi.
Thank you.
And feel free to continue the discussion on the INTAREA mailing list for now. Okay, thank you. Our third presenter, I don't see Donald in the room, so maybe we'll jump to the fourth. Is Zongpeng? Okay. Oh, he's.
Can you hear me?
Yes, we can.
Wait.
We'll just give you control.
Okay.
Go ahead.
Hello, everyone. I'm Zhongpeng Du from China Mobile, and it's the version 1 for this service routine in MEC, the draft. And next page, please. This page is about the modifications. We add some sections that briefly analyze the service routine mechanism in MEC. It's including section 4, we analyze the requirement of service routing network nodes, including the forwarding nodes in MEC and the client and the server. In section 5, we analyze the hash conflicts problem. And in the section 6, we analyze the service routine for the fixed clients, and we make some other corrections. Next page. And we will review the mechanisms. We think that traditionally, a DNS procedure will be needed when a UE, a user equipment, access the local service in the MEC. In this document, we introduce a mechanism that can access the local services in the MEC directly without the DNS procedure by using a special address. In the picture, we can see that when the UE want to access the local service, it will send 2 attempts. Attempt 1 is a normal DNS query to get the service IP, such as www.localweather.com. And the second attempt is to make a destination IP address itself by hashing the domain name. Bypass the DNS procedure. If this attempt 2 succeeds, success, the UE can access the service directly inside the MEC. We think it will it will be quick than the attempt one if the attempt to success. Next page. We here analysis the service routine IP address. We have several. We think we have several options for the service routine IP address. In the first option, we can assume that the UE can receive an MEC prefix for the service routine in the procedure or establishing the session between the UE and the UPF in the MEC. Then they can use the first, for example, 64 for the MEC prefix and 64 for the hash domain name. And in the second option, we can use the unique local address for the service routine IP address, and also the first 64 for the prefix, and the last 64 for the hashed domain name. The procedure is similar to the first option, and the MEC ULA prefix contains a special subnet ID. In the last option, we can also use all the 128 bits as a hash domain name, as the figure shows. Next page, please. Yes, thank you. This is about the section 4. We analyze the requirement of service routine network nodes. In the MEC, the network need to support forwarding of the service routine IP. And in the client and the server, they should support the binding of the service routine IP and the traditional destination address IP. We think that the value of service routine IP exists mainly in the period of establishing the connection. And after the connection is established, we can use the normal IP, normal destination address IP instead. Next page, please. We also analyze the hash conflicts between services. We think that at the beginning, we do not think that we would have too many essential services that requires this ultimate user experience. But if the mechanism is adapted widely and conflict exists between the hash domain names in the MEC, we can enable the mechanism that only on the most essential service, or we can change the hash algorithm that is running on the client and the servers to make a better hash result. We also think about several solutions for this, but it's open for discussion. Next page, please. This is the service routine for fixed clients. MEC can also support accessing via fixed clients. In this situation, we also have a gateway, the broadband network gateway as a gateway or client that can work similarly to the UPF. But we can see that a tunnel between the BNG and the MEC may be needed because the UPF perhaps the BNG is not in the MEC. And the MEC prefix can be obtained in the procedure or authentication of the client by the BNG. We also think about that perhaps several MEC may connect to the BNG, so BNG to make a decision about which MEC to connect. In this situation, they will also think the client will also send two the attempts, and if the attempt to success, it will get access to a service more quickly. And next page, please. That's all. Thank you. Thanks for the listening and welcome for comments and contributions. Any questions?
Thank you. I think.
Erik Venk. both as an entity, as an individual contributor, honestly, on this one. I wonder why you post this draft INTAREA for something which is more for me like V6 ops.
I can also share it in other group, I think, but I think it is also related to this entire working group.
I'm personally, I'm not really sure that it's INTAREA is the best place to discuss this. We can continue discussion for sure. But...
Okay, thank you.
Okay, thank you.
And Eric, again, you are suggesting a mechanism for Mac, and as far as I know, Mac is not developed in the IETF, but I guess in 3GPP. So that should rather be directed to 3GPP because there's no impact for us here.
Thank you. But I think we have used a different IP address. It should be some agreement in IETF to use the address that way.
Okay. Thank you. I think Donald is here now, so we're waiting for you. On time. Number 3. Thank you.
Okay. Hi, I'm Donald Eastlake with FutureWay Technologies. I'm going to talk about revision to RFC 7042, which talks about IANA considerations, IETF protocol and documentation usage for IEEE 802 parameters. Next slide, please. So this is part of a series of BCPs. I've been 2 or 3 before. And basically, if there's enough changes in the document, it seems to me generally better to replace it rather than try to do a bunch of updates that people have to correlate. So it mostly concentrates on the IANA considerations for these parameters, in particular the parameters that are assigned by IANA underneath the IANA OUI. And I'll explain a bit what an OUI is. And from other blocks that have been allocated to IANA by the IEEE Registration Authority. And it's got some miscellaneous related information of one kind or another, and just generally sort of explains to some extent what these 802 parameters are. Next slide. So it includes sort of from previous versions and updates, specs concerning assignment of MAC addresses. So the IANA OUI is 00005E hex. So by virtue of having that organizationally unique identifier, IANA has the right to assign MAC addresses that begin with that, either with or without the multicast bit on, which is the bottom bit of the first byte, the way IETF writes things. So those are the ranges that are shown here on this slide. They're both 48 and 64-bit MAC addresses. If you're wondering what uses 64-bit MAC addresses, the 3 uses I'm aware of are 802.15.4, which is Zigbee, FireWire, IEEE 1394, and InfiniBand. Just for your information, the IEEE will sell you an OUI if you need these blocks of addresses. And under the IEEE rules, these sort of global MAC addresses are only supposed to be used for hardware interfaces. That is to say, the concept is you'd be a NIC manufacturer or something like that. But the IEEE will also sell you for less money, a longer prefix so that you have a smaller block of MAC addresses because the number of bits you'd have available to assign is shorter at the end. IANA can also assign extended ether types, they're called. So the ether type 88B7 hex is a magic ether type, which means that it's to be followed by an OUI, and then you have 2 bytes. So anybody with an OUI can create up to 2 to the 16th extended ether types. And there's about half a dozen or so currently available, currently assigned rather, under the IANA OUI, and IANA could assign more of them. This document also mentions the address family numbers and the DNS RR types that have been assigned for MAC addresses. Next slide. This version of the BIS, 7042 BIS, adds a specification of CBOR tags for MAC addresses and Ethernet protocol identifiers. It adds information on the structured local address plan, which I'll give more details on, and company IDs, which I'll also give more details on. And it has pointers to some other blocks of things that IANA can assign. There's continuity fault management code points that were allocated to IANA, and those are assigned as specified in RFC 7319. And the registry is set up for what's called vendor specific, really organizationally specific, link local discovery protocol code points. LLDP is actually 802.1AB, and the RFC 8520 set up that registry and allocated one code point, and there is a draft, a personal draft listed there, which proposed to allocate a second code point. And this 7042 BIS actually makes some minor changes to bring that sort of in conformance to the way the RFC 7042 suggested that vendor-specific registries for code points under the IANA OUI should be structured. And this version also includes the IESG statement on requesting ether types. It used to be that any IETF working group could ask for an ether type from the IEEE Registration Authority. Those requests have to go through the IESG now. I'm not sure if the IESG would want their statement in this document, but when it goes through the IESG, I guess we'll find out, or it'll be found out. Next slide, please. So there's an allocation procedure in here, which is a little different. MAC addresses are pretty cheap. We've got lots of them. If you want 1 or 2 or 4 or something like that, MAC addresses, unless it's a pretty bad use, you probably ought to get it because, we got lots of them. However, it sometimes makes sense to allocate very large blocks of MAC addresses. Example, IPv4 multicast uses half of all of the available multicast 48-bit MAC addresses under the IANA OUI, and MPLS multicast uses 1/8 of them. So anyway, for small to medium-sized blocks, there's this designated expert. Actually, there's a couple of them. I'm the primary, and there's a secondary that can approve or disapprove it. If you want a really big block, then the IESG gets involved to ratify approval if the designated expert approves it. The way it's currently written, if you want a large block and the designated expert says no, then that's the end of it. But if the designated expert approves it, then it still has to get ratified by the IESG because of the impact on the available MAC addresses. Next slide. So what's this structured local address plan? This is a 48-bit MAC address shown here with the IETF bit ordering. IEEE tends to use the opposite bit ordering because of the physical order that bits are sent out on the wire for Ethernet. So the M bit there is the multicast bit, and that's still unchanged from before. If it's 0, it's unicast. If it's 1, it's multicast, and it's also 1, of course, if it's broadcast, which is all the bits on. There's this X bit, which is formerly the local bit, and if it was 0, it meant it's a global unique address, which is still true. And it used to be if it was a 1, it just meant local, and means the local network administrator had control over things. But it's been renamed X, and there's a couple more bits that now have effect because for various reasons I'll get into, they decided that the local address space should be divided into 4 quadrants with, and this is actually an optional split right now, but it's the way things are going, so I think it'll become somewhat less optional in the future. Next slide. So here we go. This is what the 4 quadrants are with the X bit of 1. The next 2 bits above that are 0, 0. It's just like current local up to the local network administrator. 0, 1 is assigned to a CID holder. I'll explain that in a sec. 1, 0 just sort of reserved. Obviously, local network administrator can use that, but who knows? They sort of reserve the right to assign some other use for that quadrant. And 1, 1 is standard assigned, which is intended to be assigned by a local dynamic MAC address Allocation Protocol. And this is basically to answer the need because of virtual machines and because of Internet of Things devices, both of which can be quite numerous and dynamic. It's a violation of the rules to use these globally unique MAC addresses for that sort of thing. So you just wanted some protocol to assign them locally and dynamically. So there's no reason for this to be exclusively any particular protocol from any particular organization. IEEE has 802.1CQ. There's a couple RFCs on how to do this. So looking back at what exactly is this OUI? So OUIs represent organizations. They're 24 bits. They have the M bit 0 and the X bit 0. So that's great. And if you have an OUI, you automatically have the right to assign a bunch of unicast and multicast globally unique MAC addresses. So there are people who need company identification, but they don't really need necessarily this block of globally unique MAC addresses. So that was the idea of the CID. So it has the local X bit of 1 and the Y bit of 1, Z bit of 0, and that basically indicates that it's the top 24 bits are a company identifier. And if this structured local address plan is in use on the local network, then you also have MAC addresses you can allocate locally. This is somewhat similar to the IETF thing that used to be in RFC 2153 for PPP, where there was a block of things which were called CF series OUIs, although I think this was somewhat the IETF stepping on the IEEE's toes. Only about a half dozen, I think, were ever assigned in this series. So those have all these M, X, Y, and Z bits of 1. The multicast bit is meaningless for the PPP use that it was originally intended for. So that's been deprecated. And the only other funny thing is interesting is that IPv6 multicast has always been defined to use MAC addresses with the top byte being 33, which actually falls into this administratively assigned quadrant. And it's interesting, if I mention this to some people in 802 who've never heard of this, they say, that's terrible. You know, this is camping on stuff that belongs to us, and IETF should fix that. Of course, it's baked into hardware and has been for many, many years. And I talked to other people that say, oh yeah, we knew about that. We talked to them at the time. It's okay. So anyway, next slide. So there's also some stuff in here. It adds some documentation and example code points where there weren't before. The 2 RFC sites cited there are just RFCs that explain why it's a good idea to have documentation and example code points. And there's, you know, there are various clarifications in the document and some minor changes from before that I didn't get to here. I recommend you take a look at it if you're interested in this sort of thing, so you can see what's there. Next slide. So what should be done with this document? I'm fine with it going through the INTAREA working group, or it could be AD sponsored.
Thank you, Donald. Any question, comment? Otherwise, the INTAREA will go ahead, JC.
Thanks, Wasim. Yeah, I think this document makes a lot of sense. And Don, I think you did a great job at encompassing and compiling all these latest events. Definitely, you participate very well in IEEE 802, and then you're well aware of all the latest and greatest. I personally think that this makes sense to be adopted in INTAREA so that we can have some more discussions and perhaps add some more references if need be, and have the group discussion. So I think it would make sense to get it adopted in INTAREA.
Thank you. If anybody has any suggestions for additions or corrections or whatever, happy to hear them.
Carlos Bernardo, UC3M. Just a comment that we have RFC 8948 that basically are extensions for DHCP to assign MAC addresses considering the slab quadrants. Just for you, maybe it's
I think I mentioned it here, and I don't remember whether it's mentioned in the draft right now or not. But
okay, I haven't checked the draft. Apologies, but just as a potential reference that you may consider. That's it. That's my only comment.
It's something that should be mentioned in the draft.
Okay, thank you. We'll do a call for adoption. Thank you. Okay. Thank you all. This was our last presentation. So thank you for your time, and see you in London.
Thanks, everyone.
Still. Thank you for the support, Eric. I'm feeling a bit dizzy today, actually. Yeah, I don't know why, but we'll see how this will go. I prefer to do it back in the area, so yeah. Ah, okay.
Okay, there is one restaurant in a hotel nearby. I don't remember. It's on the 60th floor, and the elevator goes directly from there to the 60th floor. So that you really notice changes.
Okay.
I mean,